Hi everyone. Let us see the another important aspect of the tool which we have constructed so far after the item analysis and also after either exploratory factor analysis or confirmatory factor analysis. We have to go for the reliability, validity and norms. Now let us take up the reliability. What does the reliability means? They say no, the score should be reliable. Reliable means refers to the consistency of the scores, which means that if I get 10 out of 20 in a test today, after 2 weeks, if the same test is kept again, I have to get around 10, maybe 11 or 9. So that is what reliability, that is what the consistency of the scores. I should not get 20 out of 20 when it kept for the second time. So consistency of the scores. Reliability, it has a value and direction. So it is a vector quantity. So let us see. See if it's a positive, then it means that if there is an increase in x, there is also increase in y. If it's a negative, if there is an increase in y, there will be decrease in y. So x increases, y increases positive, x increases, y decreases negative, negative correlation. So that's what the positiveness means. And the range will be, it starts from so minus 1 to 0 and to plus 1. And these are the norms. When you get plus 1, it is perfect positive or perfect negative, plus or minus 1, perfect positive or perfect negative correlation. When it is become zero point 0.9 to 0.99, it's very high positive or negative correlation. So likewise, the interpretation course. These are the norms for this course. So if we have more sample also, then we can see the values. The values may decrease also. Suppose if we have taken some 20 samples between correlation between x and y. So if we have 20 samples, so here also 20 values, and if you go for correlation, and then the degrees of freedom will be minus 2, we'll be having 18. So in 18 we have to see what are the zero point 0.5 in social sciences. When it's a two tail test, we have to go for either 0.05 or 0.01. So if we have taken 20 samples, and after the degrees of levels of freedom, it will be 18, and in 18, if it is 0.444, then it is significant for a 0.05 level. If it is 0.561, then it is significant for 0.01 level. So as the sample increases, then we can see how far. So suppose if the sample is 1, you see after the degrees of freedom, if the sample, you see the value for 0.05 and for 0.01. These are the values. If the sample is 1, and if its sample is 20, and after going for degrees of freedom 2, then we have, these are the values. So as the sample increases, the value decreases and it will be significant. So types of reliability. Reliability means when a change in the variable x causes a change in another variable y, there is a relationship. If a change in one variable is accompanied by a change in another variable, then it is a, then both are reliable. So we have four types of reliability. Measuring the reliability, one is measures of stability, consistency over a period of time, test, retest. Suppose I have taken a test today, and if I have taken a test after 10 days, the source should be consistent. This is called measures of stability, stable. Measures of equivalence. Suppose we can prepare test A and test B based on same objectives. We can have the objectives as same. We can have one set of questions in question paper A, and we have different sets of questions for question paper B, which has the same outcomes, objectives. Benjamin Bloom's taxonomical. And if you go for reliability of A and B, then that is called as measure of equivalence. Stability is for time period and equivalence is for two different sets of a question having same objectives. A scale will be having of 20 or 40 items. If you go for the internal reliability, then that is a splitman. And if there are more than one people takes takes the measurement with the same tool, then we have to go for inter-rater reliability. If there are more than one person, so uses a tool, then we have to go for inter-rater reliability, otherwise known as tester's reliability. Okay. So if we have a nominal data, not interval, not ratio, we have to go for point biserial correlation. And this is what we have taken for a point biserial correlation. If the scale possesses an achievement and also a right wrong question, then if you want to go for correlation between the achievement and a right or wrong questions, then this is a variable view. This is the data view. For example, we have taken 10 and then correlate, bivariate. In SPSS, we are going both the variables both the things you transfer into variables, and then you check here the Pearson's correlation, two tail and flank significant. So if the star is 1, so it is 0.05% significant. If the star is 2, this will be 0.01. So the levels of significance we have transferred, and then we see the correlation is 0.550 and with significance 0.05. Therefore, it's greater than 0.05. Therefore, this is not significant at all. So this is a if the data we have as a nominal data, right wrong questions are there in our items. We have right wrong questions and related to the achievement of a particular sample, then point biserial is the way to find the point biserial correlation. Okay, then let us go for interval ratio data. If there are two variables and both are interval ratio scale, then how we can go? The same procedure. And we have taken achievement and intelligence, both are interval scale. Same we correlate, bivariate, transfer that, and then check Pearson correlation coefficient, two tails, flag significant. So in options, we can also check if you want means and standard deviations, statistics. So this is the correlation between two things, achievement and intelligence. So we have here 0.994. So you can see two stars are there. Therefore, it is at zero point zero 0.01 level of significance. So this is how we find the correlation between two things or two items. So if there are more items, we have constructed 20 or 40 or 30, we can go for the split off reliability of our scale. Suppose we have a scale of 1 to 15 or 1 to 10, let us take. So split half. Let us divide the scale into two halves. What is the correlation between this half and this half? Then that is called split off reliability. So here, for example, I have taken 10 items, and these 10 items is given to 198 sample, and we are going for split off. See, the measure is in scale, and it is not in nominal or ordinal. So the option in SPSS is scale, reliability analysis, and then transfer all. We had 10 items here, it would have been here. Transfer all those items here, and model we have split off. If you click statistics, we will be having descriptives for items, scale if item deleted, and inter-item correlations. So then click continue, and here is the results. So we have the Spearman Brown coefficient as 0.507. So this is our correlation coefficient 0.507. Okay, so therefore what we have to do is we can go for statistics. The inter-item correlation you can see among all the items. So item number 1 with item number 2, item 3, etc. Likewise, item number 2 with 1, 3, etc. So likewise it goes. So these are the second one is the We have asked for descriptive statistics that has been given for 198 sample, mean, standard deviation, and then n. So now we'll go for the last thing. So the last one is the important one, where we can see the what is the correlation if a particular item is getting deleted. So that is the last statistics which we have to go for. So here it is. So here you can see item number 1. If this item is deleted, the correlation will be 0.262. If the item number 2 is deleted from the scale, the correlation is 0.309. Likewise, if the item 5 is deleted, the correlation is 0.525, which is more than Spearman-Brown coefficient. Therefore, item 5 can be deleted. Likewise, can you find what are the other item can be deleted? You can see the item 8, 0.5 this also can be item 5 and item 8 can be deleted from the scale. This is the usefulness of split of reliability. So if we have a scale and if it is bound to used by more than one person, we have to go for the tester's reliability. And it is in the same way how we have found achievement and intelligence if it is in ratio or interval scale. The same way we have to find out. Or simply this is an example. Suppose there are many reality shows in TVs and where there are many judges, they will assess normally 2 or 3. And if a contestant is there and if it's assessed by judge 1 and judge 2 and they are giving same mark, the agreement is 1. If for the contestant 2, the judge 1 is giving 7 and judge 2 is giving 6, so agreement is 0. So likewise, we have to put 1010. This is of nominal type, 1010. And overall, what is the agreement? 3 out of 5 is the agreement. Or otherwise, if it's in a, if the observer A measures in an interval or a ratio scale, if you have many measures and observer 2 measures also is there interval or ratio, we can go for Pearson correlation coefficient as like we discussed previously. This is how we are finding the reliability. Thanks all. We will meet in another video. Thank you.